Hey, this is Dr. B, and let's design some catalysts and think about activated complexes, and let's also do some reaction rate problems, equilibrium problems that have to do with Le Chatelier's principle. Okay, looking at problem 31, it asks you for a given chemical equation, balance it, draw an activated complex, and suggest a design of a catalyst. Now, this is not a typical problem you might see in a textbook, but I think it's a useful exercise. Balanced chemical equation's easy enough. For the activated complex, we'll simply assume a concerted mechanism where all bonds are breaking and forming simultaneously. And for a simple catalyst design, we'll partially surround that activated complex such that the molecules are forced into that position so that collisions at the right location are inevitable. Okay, the first one's done for you. We're reacting carbon with oxygen, so it's a 1:1:1 reaction ratio, and the bonds that are breaking are oxygen to oxygen double bonds, and we have 4 carbon to oxygen bonds that are forming in the form of 2 double bonds each. Notice that using dots sadly does not differentiate between making and breaking. We partially surround it with the catalyst that shows you that that's what catalysts like to do, force things into their correct positioning. And that would be the answer to question number 31. For 32, it's magnesium with oxygen to make magnesium oxide, but in this case, the balanced chemical equation is 2:1:2. In these cases, it's a good idea to put the thing that only is one of in the middle, in this case oxygen, since there will be no magnesium to magnesium bonds making or breaking. Break those oxygen double bonds, make all those magnesium to oxygen ionic bonds, and you have yourself an activated complex, and perhaps the catalyst would have a shape like that. The reaction of hydrogen with oxygen to make water is similarly 2:1:2, so put your oxygen in the middle. Break those oxygen double bonds as well as the hydrogen single bonds there. Be simultaneously forming the 4 hydrogen to oxygen bonds that comprise water. Surround it partially with a catalyst. We don't surround it totally because we want to remind students that you don't want it to get stuck in there. To have a high turnover rate, you should be able to have rapidly formed molecules leaving and new reactants arriving. Let's do some equilibrium problems regarding Le Chatelier's principle, which is simply that for a chemical reaction, you can shift the equilibrium to the right by adding reactants or removing products, or heating it if it needs it, meaning if it's endothermic, or pressurizing it if it helps, meaning if it forms a fewer number of moles. Okay, let's go ahead. If we add hydrogen for this reaction, it's a reactant that should help shift it to the right. Add chlorine, add chlorine. I'm sorry. If we add hydrogen, that will decrease the concentration of chlorine since it's a reactant, right? It will increase the concentration of hydrochloric acid because it's a product. K does not change for anything except temperature changes. So do that whole column. For adding chlorine, that's also a reactant, so same deal, right? It's asking for hydrogen. That is the reactant, so it will decrease its concentration. We're not going to talk about chlorine really because you're adding it, which by definition increases its concentration, while at the same time it shifts the reaction to the right, so it could be a wash. The hydrochloric acid concentration, if this is shifted to the right, will increase, and K doesn't change because the temperature does not change. Adding HCl is a product, so that's going to shift to the left, making the concentration of hydrogen increase and the concentration of chlorine increase while keeping K the same value. Removing things. Removing hydrogen creates a hole there, if you will. At least that's how I think about it. Shifting things to the left, thus increasing the concentration of chlorine, decreasing the concentration of the reactant hydrochloric acid while not affecting K. Removing chlorine, same deal. It's a reactant, so shifts things to the left while increasing hydrogen, decreasing hydrochloric acid, keeping K the same. Removing HCl is a great idea if you want things to go forward. Destroys that equilibrium since the reverse reaction cannot occur. It's definitely going to go to the right. The reactants will decrease in concentration, The product will increase, but it's, the thing that's being removed, so it could be a little harder to answer. No temperature change, so K is the same. Now, finally, a temperature change. Yay, that should increase K. And does this reaction need it? Well, actually, no, it does not. It's exothermic. It produces its own heat. So it'll have the opposite effect. It'll shift things to the left. Why did I write right? There is no way that's correct. So increasing the temperature, please change that, right? This does not heat it. It'll change. So I'm going to do this correctly. It'll change the equilibrium to the left. The hydrogen concentration will increase. The chlorine concentration will increase as well. The HCl, since it's going to the left, will decrease, and the K value will, if you heat it up, if it's going in the wrong direction, it will actually decrease it. So I would like you to change all of those. I'm convinced that's true. Decreasing the temperature is a good idea because this thing does not need heat. It generates its own. So I'm guessing these will all be opposite as well, but that's fine. Please just change them as you go. It's a good idea, so it's going to go to the right. It will decrease the hydrogen concentration. It will decrease the chlorine concentration. It will increase the HCl concentration. And since it's a good idea, it'll increase your K value. So opposite for all those two. Thank you. Pressurizing. It's going to be a wash because 2 just turns into 2. So same, 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 same. And no temperature change, so same as well. Decreasing the pressure, it's a wash as well. And adding a catalyst is always a good idea. What will this do? It will definitely shift it to the right. Adding a catalyst, that's incorrect. Adding a catalyst will help. No, no, no. We are talking about equilibrium, aren't we? Right? We're not talking about rate. It will make it go faster, but will the equilibrium shift? No, because catalysts help in either direction. So I agree with these answers. Same, 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 same. And you might think that it helps the K value, and certainly it helps the rate K, but equilibrium, no. It lines things up perfectly for the forward reaction as well as the reverse reaction. So same for all. Those were some equilibrium problems as well as some rate problems.